Albedo is a word that means the amount of light reflected. Therefore, the bigger the number, the more light reflected. Now, let's think back to the lab I just had you do with the Lux camera app. We had a dark object that had a very low number and a lighter object that had a much higher number. So notice the darker color at a lower number with a lighter color at a higher number. So I think we all are pretty familiar with that, where the idea of you should wear dark colors in winter because it absorbs more heat, light colors in summer because they reflect more of that light, more of that heat light. Well, that is absolutely true. So, and I want to remind you of this general concept of physics where if the colors of the light coming from the sun are all of the colors, Roy G. Biv, all of the colors of the rainbow, then what happens is that the color of the object we see is the color of the light that is reflected. All other colors are absorbed. So notice I spelled out the word absorbed here using all of the colors except for green, because the green was reflected. All of these colors were absorbed. Now, okay. So an object with a low albedo, so like a dark color, that means there is lots that was absorbed because it's not reflecting back anything. You've got to remember, black is not technically a color in terms of physics. It is a lack of light, a lack of any radiating light. So that's why we wear darker colors in winter, because they absorb all of that light energy and keep us warmer. A higher albedo, that would be lots of light reflected, so there's less heating and things are less warm, so that's where you would wear light colors in summer to stay cooler. Now, with the albedo lab that I would have had you do if we were in class, I would have had you take the albedo of something that is black, medium brown, green, blue, light brown, and then white. And you would have entered all your data and we would have found out, like, okay, the lowest albedo is the stuff that is black down here. These are things like such as fresh asphalt, very fertile dark soil, volcanic rock, and roofs, whatever. And that kind of land surface is going to be warmer. Then we have over here like a white surface, like snow or a white roof, glaciers and clouds. Those have a very high albedo. They reflect a lot of the light. So these things are less warm. Now, when we talk about these things in terms of surface colors and climates, if we look at an overall environment throughout a year, the darker colored areas are also going to be wetter, because what happens as the temperature is warmer? What happens to the liquid water on the surface? Well, it melts and or is eventually evaporated. If it evaporates more, then we have more condensation, we have more clouds, and so a wetter climate. Where it is less warm, i.e. colder, there is not as much evaporation. So in general, less evaporation, less condensation, less precipitation. So it's just drier. Now, also along with these darker colors, it's not just that it's wetter and warmer. We also get more of the water extremes, because we can get things such as droughts in some areas, floods in other areas. So that's just more more evaporation. And so therefore these extremes such as droughts and floods. Now, if you take the time, look through the notes to see what I said about the types of surfaces that go with all these different colors. Now, let's take a look at some information here about anthropogenic biomes of the world from the 1700s, so old, and the 2000s, modern. We've talked about the word anthropogenic so many times now, but we're talking about man-made biomes. So land surfaces on Earth that are what they are because of people. Or in some cases, some of these colors are actually referring to these ones right here are semi-natural, woodlands and so forth, and wildlands, like completely natural. Over on this map, you'll notice color-wise, we see a lot of the gray, the dark gray, some of the light green, the seafoam green, if you will. Very little yellow and orange. So the point is that this is mostly these gray and green colors. Here in the 1700s, there's a little bit of these rangelands. Now, if we look at the modern world, we see that this land surface, there's a lot of blue and purple, orange, tan, yellow, even some red in there. We look at what those things are. These are the rangelands, the croplands, the urban and suburban settlements, the villages. These are all human land surface things. So what we really see here in the last 300 years is that there have been lots of surface changes done by people. This is mostly cultivating what was otherwise wild and natural environments into what is now farmland or places where we are living. Now, what has this done to the overall climate on Earth? Well, it has caused shifting because as we make these changes about land use the land use of the surface, we are changing the color of the surface. As we are changing the color, we are therefore changing the albedo and therefore how much light is reflected or absorbed. Generally speaking, the changes we are making are generally going from lighter colors to darker colors. So with all these words I've written here, what I'm really saying is generally we are changing the surfaces to whereby things absorb more energy because they are darker. For instance, as we are through various things causing the earth to warm up, that's melting glaciers and exposing darker colored. So we're getting rid of the white in place of open ocean, which is blue, which is darker than white, or we are melting the ices and snows, and we are getting anything else depending on what is underneath it, all of which is darker. There's a lot of things that we are doing, such as going from whatever natural land it was to things such as asphalt and roof tiles, empty crop fields as opposed to the green forests or crop fields. By the way, the crop fields are empty in the times of the year when it's not in season and so forth. So if we look at the overall averages of the land use changes we are doing, we are shifting things this way towards warmer and wetter and more of the extremes with droughts and floods. So with this energy budget on Earth, we're talking about the energy in, as I've highlighted in this orangish color, and the energy out. It's been what it has been for millennia, for thousands of years, hundreds of thousands of years, millions of years. But in the last several hundred years, we've been changing the use and therefore color of the surface. So we've changed the balance. Generally, we've changed the surface to be darker and to absorb more energy. So this is all yet another reason people are influencing the climate on Earth.